Okay, so another task for today. Let me try to connect my Bluetooth tablet. Bluetooth settings. Okay. Bluetooth. Wacom Intus paving mode. Press and hold the power Bluetooth button until the bullet starts blinking slowly. Okay. Doesn't work. Is it power? Yeah. It connects instantly to my laptop. Okay, whatever, I'll connect it using cable. Okay, so I'll be solving this problem. No, not this one. This one, not this one. Perfect squares, yeah. So I need to find the number, if like the number can be represented by the least number of perfect squares that sum to n. So what I'll do, I'll have this function def, let's call it f, and then I'll have this number inside int, and then I'll say I have dp as a cache, and then int, let's say gonna be dictionary with int and int, something like that, and then it should return the integer. And then if, so my idea is like to have the recurrence. So the question is like if a number can be represented by a number, if the number, what's the minimum number of perfect square that can represent the current number? So like it should be a1 squared plus a, let's say, s squared. And there, like, I can always, like, this number a's, a1, as, they can be repeating number, and any number can be like from 1 to 10 to the power of 4, like basically any positive number, or even 0, can be represented as a sum of ones, yeah, and a sum of like num ones, and like 1 squared is gonna be just 1. So this can be replaced like as a 1 squared plus 1 squared, and the number here of this one is gonna be num. So the answer always exists. The question is, what's the minimum number of num of s? So s should be mean. And like a should be like a's should add up, squares of them like should add up to the num. So what I plan to do is like to do the following. So I can say f of x equals what's the minimum number, mean number of perfect squares to represent x. So I can always find, I can like write a recurrence formula. F of x gonna be equal minimal 1 plus, or like not even 1, yeah, 1 plus f of x minus minus, let's say, k, where k is equal from 1 to what? 2 square if minus k squared where k from 1 to the square root of x. And here even I can do so, and then f of 0 should be equal 0, and f of 1 should be equal 1, and then so this formula should give some insight how I kind of, based on the previous number of x, how I can get the current number of x. And I can do that from top to bottom. Let's say I need to find, like, say n is equal to x is equal 12. So x of 12 gonna be minimum between the following: 1 plus f of 11, and then 1 plus, here, like, k is equal 1, k is equal to f 1 plus f of so 12 minus 4, 8, here 1 plus k of 3, f of 3, because 3 squared gonna be 9, 12 minus 9, 3, and that's all. Because if I have k of f4, it's already gonna be, so it's like square root, and then I'm gonna be downcasting to the nearest integer from the left. So if k is f4, like, gonna have 16, 12 minus 16 already negative, so it's like, and then square root of 12 is roughly 3, so up to the 3. I need to calculate this one. And then for this one, let's say I want to calculate f of 3. F of 3 gonna be minimal between 1 plus f of 1, and that's all. F of 1, oh no, not f of 1, f of 2, because the next k gonna be equals like 2, and square root of 3 is like equals 1 something. So this one just equals 1 plus f of 2, and f of 2 is gonna be just equals 1 plus f of 1, and f of 1 I already know it's 1, so this is 2, and f of 3 is gonna equals 3. So this one I can say that this one is equals 3. And if I do the f of 8, so f of 8, So as you mentioned, I already calculated f of 0, f of 1, and f of 2. So f of 0 like already in the map, and f of 3. So let's calculate f of 8. F of 8 gonna be f of minimal, and then here gonna be 1 plus f of 7, and then 1 plus f of 4, and that's it. F of 4 gonna be minimal between 1 plus f of 3. I already calculated this one. It was 3, and this one was 2, this one was 2, this one was 3, this one was 1, this one was 0. So f of 3, so f of 4 minimal between 1 plus, so it's going to be 4, and then 1 plus f of 0, because like 2 to the power 2 squared going to be 4, 4 minus 4 0, and this one is equal 1. So f of 4 is actually equals 4. Oh, 1. So next one, f of 8. I need to, this one is equal 1, and then I need to calculate f of 7. Oh, this one is actually 2, because f of 4 2, oh, f of 4 1, and then 1 plus 1 2. And this part gonna be f of 7 is equal minimum between f of 6 and then f of 3, 1 plus f of 3, 1 plus f of 6. F of 3 gonna be 3, this is 4. F of 6 gonna be minimum between 1 plus f of 5, and then 1 plus f of 2, and f of 2 is equal to 2, so 3, and f of 5 gonna be 1 plus f of 4, so this one 2, or 1 plus f of 3 4, so like this is equal to 3, so 3, f of 6 3, and this one 3 is also f of 7 equals 4. So we already know f of 7 is equal to 4. This one is equal to 2, so f of 8 gonna be equals 2. F of 8 equals 2, and in between I calculated a lot of like interim values, so f of 5, f of 6, yeah, so all these values, these can be like they can be stored in a cache or like DP map, and then I don't need to come back again and like calculate them. I can just quickly look up them and return the answer immediately. So in this case I have this if num is equal 0, I'll return 0. If num is equal 1, I'll return 1. If dp get num is not none, I'll return dp get num, or like even this dp num. Otherwise I'll do that for I in range int num to the power of 0.5, so this character plus 1, and then from range from 1 to this one, I'm gonna go res is equal, say num, and then res gonna be equal min res, and then 1 plus f of num minus I to the power of 2. And then I'm gonna save it in a dp. Dp num gonna be rest. And in order to call this function, I'm gonna call it somewhere here. So I'll create cache, or like dp is equal empty map initially, and then I'll call f return f num, or like n, and then dp. And that's gonna be it. That's a whole solution. Oh, in the end, I wanna rest return rest. And here also dp. Interesting. Why is number exceeds 45? Case of 45. So this one, 13, let's check. $45. What? Oh, I know. Oh no, or maybe no. What if I gonna move this function outside? So self. I wonder if it's because let's say self. Okay, self. Should I call this self f? Self. Interesting. let's print fdp dp. It's never updated. That's interesting. Why? Okay. So let's say for key value in enumerate dp, I wanna do print dp k, let's say k, let's say pass equal self f, and then key, and then key, and then value equals v, and then return pass called calculate here, and then calculate here. Yeah, for whatever reason, like I cannot see why like this is not right values actually. So k of 4, the value should be 2. Let me stop. So I eventually figured out what the problem was with the solution. I guess I got used to that Rust syntax, and like I just wasn't returning the result here, and this should fix the algorithm. That's it. I can definitely do something like more elaborate, like put the dp0 equals 0 and the dp1 equals 1, and then do something like this. There are a couple tricks here and there. What the editorial? Nothing editorial says. A better measurement. Though there is a this algorithm that says like 4 squares always suffice to find is, I guess, some kind of Lagrange 4 square theorem. So split it into 4 parts and then do a few interesting tricks here and there. So this is basically looks like this is looking like binary search problem. So 4 is gonna be at least 4. Oh, like maximum 4 squares. And then sometimes it's gonna be 3 squares. And sometimes it's gonna be 1 and 2 squares. Yeah, I'm gonna wrap it up.